Okay, welcome to lesson 3 of unit 1. In this lesson, we're specifically going to talk about arithmetic sequences, which is going to just continue along the sequences lesson that we had last night. So an arithmetic sequence is a type of sequence or a specific type of sequence that we're going to look at. In this type of a sequence, the difference between consecutive terms is constant. So when I look at two terms that are right next to each other in my sequence, I'm adding or subtracting a constant number to get to the next term. So let's look at an example of what an arithmetic sequence will look like versus what it will not. So if I look at this first example, 14, 10, 6, 2, and -2, to get from term to term, my constant difference, or what I'm doing to get to each of these, is I'm subtracting 4. And so this would be an example of an arithmetic sequence because I'm doing the same thing each time and it's adding or subtracting a value. So that's what makes it an arithmetic sequence. Versus in this sequence, this is not considered arithmetic because to get from term to term here, although I'm doing the same thing every time, instead of adding or subtracting, in this case I am dividing each of these terms by 2. So adding or subtracting makes an arithmetic sequence versus multiplying or dividing makes a geometric sequence, which we'll actually talk about later. Don't worry about that for now. So the second piece along with arithmetic sequences is the common difference, and I kind of I said this, you may have overheard me, that the common difference, or D, we use that variable D to represent it, is the difference between consecutive terms. So to get from one term to the next, what am I doing? And so in the example that we went over up here, and this is only for arithmetic sequences, I should clarify, my common difference, or D, would equal -4. There is no D value when I'm multiplying or dividing by something else. This number is called something a little bit different. So let's look at an example of a sequence. I want to find the common difference between each of these terms. What do I have to do to get from term to term? Take a minute to yourself. And if you got that I should be adding 2.5 to each term, you are correct. My common difference will be 2.5. If I were subtracting, like I was up here, my difference will be negative. Okay, moving right along. So in the last class, we went over the recursive form of sequences, and this applies to arithmetic sequences. And we're going to talk a little bit about a different form, but for now, let's just start off with that. So as a reminder, with the recursive form, my first step is to list my first term. And then the second piece of it is to tell me how to find u sub n, how to find any term, by using the term before it, u sub n minus 1. So let's just practice with an example. So in that last sequence, and I'll recopy it up here, 3, 5.5, 8, 10.5. If I want to know the recursive form of that sequence, what do I need to list? What will the recursive form look like? So if you answered that u sub 1 is equal to 3, and u sub n minus 1 is equal, or sorry, u sub n, not u sub n minus 1, u sub n is equal to u sub n minus 1 plus 2.5, you are correct. And so just connecting these two, I didn't mention this, but when we're working with arithmetic sequences, you're adding the difference. So with that last example, we identified 2.5 as our difference, so it shows up here. just like it does over here. And this is useful if I wanted to find, let's say, just the next term in this function. So I've got 4 terms here. If I wanted to take u sub, or find u sub 5, I would take u sub 4 and add 2.5 to it. But this term is, or this form is pretty restricting. It doesn't allow me to find, if I wanted to find u sub 100, or my 100th term, it would take me a while to figure that out. It would take a lot of adding, and it would be very time consuming. So that's why we want to use a different form that's a little bit more useful. And I mentioned that we would have a slightly more useful form in this lesson. So we're going to talk today about the explicit form and how to find it, how to use it. So the explicit form is this formula. U sub n, so any term, is equal to u sub 1, my first term, plus n minus 1 times the difference, where n is the term number that's over here. So if I were to find the 10th term, so u sub 10, then my n value here would be 10. Let's look at an example of how to find this form. So using that same sequence, 3, 5.5, 8, 10.5, if I want to find, and I'll leave that on the screen, if I want to find the explicit form, let's just move this down a little bit. If I want to find the explicit form, so u sub n is equal to u sub 1 plus n minus 1 times the difference for this sequence. So there are a couple different pieces that I need to know in order to use this function. My unknowns are u sub 1 and my difference. So those are the two pieces that I need to fill in. My n's in here are just variables. They're going to be left exactly as they are. Think of them like x in an equation. So in order to figure this out, and I'm just going to move this up a little bit, I need to know what is u sub 1 and what is the common difference. Go ahead and pause. You should get that my u sub 1 value is 3 and my common difference is 2.5. And so now that I know those values, I can substitute them into that formula. So I'll get my explicit form is u sub n equals 3 plus n minus 1 times 2.5. And so this is the explicit form for my function, the explicit form for my function. Okay, so why is this useful? Well, this makes it a lot easier if I wanted to find a slightly larger term. So let's say I wanted to find u sub 9. Right now in my sequence I only have 4 terms, so it would take me a while to get there. I would have to add 2.5 a couple of times. Not as bad as u sub 100 or my 100th term, but it would take a little bit to find my 9th term. So to find my 9th term, I've now replaced n with 9. So anywhere else in my equation over here, I'm going to substitute in 9. So u sub 9 is equal to 3 plus, instead of n, I'm going to put in 9, minus 1 times 2.5. Okay, now I'm going to just simplify, and once I simplify this, I will have my 9th term. U sub 9 is equal to 3 plus 8 times 2.5. By 8 times 2.5, that's going to give me 20. 20 plus 3 is going to be 23. So my 9th term in the sequence is the number 23. And so if I jumped up a little bit, eventually my 9th term, u sub 9, will be 23 in this sequence. Okay, let's keep moving on. So there are going to be a lot of examples in this video, so don't worry if you get a little bit stuck. So I've got u sub 1, u sub 2, and u sub 3 of this of a sequence, and I want to know in the end what is u sub 18. So in order to find u sub 18 easily, I first want to find the explicit form. So using this formula up here, what is the explicit form for this sequence? Go ahead and figure it out. Okay, so you should have figured out that your explicit form is u sub n equals 8 plus n minus 1 times a negative 5. To help you get there, you should have answered that your common difference going between these terms is subtracting 5. So since I'm subtracting 5 between these terms, my difference is going to be negative. Okay, now using this, now that I have my explicit form, I want you to solve and substitute in what is u sub 18 equal to. Go ahead and pause. U sub 18, I'm going to substitute 18 in for n. When I go ahead and simplify that, I'll end up with 8 plus a negative 85, so my final answer for u sub 18 will be negative 77. So let's look at another example. If I've got this sequence, negative 7, negative 1, 5, 11, I want you to tell me what is u sub 10. So stop, and you're going to find the common difference, find the explicit form, and then lastly, tell me what is u sub 10. Go ahead and answer these 3 questions. An example, and I'm just going to move this up so that we have some more space, where I'm not necessarily given all of the information that I need. So maybe I'm told what u sub 5 is and what u sub 11 is, but I don't necessarily know what the difference is. I don't know what my other terms are or what my u sub 1 is. And so those are all things that I need to know in order to figure out my explicit form. U sub n equals u sub 1 plus n minus 1 times the difference. So let's figure that out together. So to figure out my common difference, it's similar to calculating slope. I'm going to take the difference between my terms, so 64 and 22. Those are always going to go on the numerator. So terms subtracted. And then I'm going to put that over the term number. And again, I'm going to subtract those 2 values. So here's what I mean by that. The terms are the values that I've squared here. So 22 is my 5th term. 64 is a term in my sequence. So to find or calculate my difference, I'm going to subtract these 2 numbers. I'm just going to try to keep this positive because I don't really want to deal with the negative. So I'm going to subtract the smaller number from the larger number. So I'll have 64 minus 22 in my numerator. Then in my denominator, I'm going to subtract the term numbers in the same order. So my term numbers are my smaller subscripts, so 11 and 5. And just like slope, how you do y2 minus y1 over x2 minus x1, I've got to keep the same order. So 64 goes with 11, so I'm going to start with 11 over here, and subtract 22 goes with 5, 5 from 11. When I simplify this, 64 minus 22, that's going to leave me with 42. And 11 minus 5 is going to leave me with 6. When I simplify 42 divided by 6, I'll be left with 7. So my common difference in this case will be 7. So this is your first step to finding your explicit form for the most part in every single circumstance. I always need to start with finding my, my common difference. So from there, if I substitute in what I know so far, I've got u sub n equals u sub 1, so I don't know what my first term is, plus n minus 1 times 7. So I don't know what u sub 1 is, but I do have these 2 terms. I want you to brainstorm for a second. How can I use these 2 terms to solve for a u sub 1? Take a guess. Okay, if you wrote that you should substitute in one of these terms, you are correct. So I can pick either one. I'm going to pick the smaller one to deal with the smaller numbers. So I'm going to replace my n's with 5. So instead I'm going to have u sub 5 equals u sub 1 plus n becomes 5. 5 minus 1 times 7. Okay, so right now I'm still not completely there because I've got two variables. But I know what u sub 5 equals. What can I substitute in for u sub 5? Great, you should have answered 22. So I'm going to replace u sub 5 with 22 equals u sub 1 plus 5 minus 1 times 7. And now I'm good to go. I can simplify and solve for u sub 1. So 5 minus 1, that's going to give me 4 times 7, plus u sub 1 is equal to 22. 4 times 7 is going to give me 28, plus u sub 1 is equal to 22. If I subtract 28 from both sides, I'll get that negative 6 is equal to u sub 1. So now I have all of the pieces to write my explicit form. I've got u sub 1, and I've got my difference. So I'm into my third step. My explicit form is going to be u sub n is equal to negative 6 plus n minus 1 times 7. And that's the end. Okay, one last example. Now you're going to try if I've got u sub 8 and u sub 15. Start with your common difference. And then you're going to find or figure out what u sub 1 is. And then lastly, you're going to tell me what is u sub n equal to. And that's the end of this lesson. Good luck solving. We'll talk about it after you're done.